Hello, this video is for learning intention number 19, and this is all about solving trigonometric equations. And I have an example here. I need to solve 2 cos 2x plus root 3 equals 0 by giving the general solution. So I'm going to do this two ways. The first way I'm going to solve it is by giving the general solution. And then the second way I'm going to do it is if they give you a domain that you have to solve it over. So they might say, I don't want the general solution. They might say, I just want the solutions from 0 to 2 pi. Let's start with the general solution. The first thing you do with this is you transpose it. So the first thing to do is a bit of algebra. Here's our equation. Let's minus the square root of 3 from both sides. And let's divide both sides by 2. There we are. Okay, we've done our algebra. Now you have to be able to recognize the key angle. And this is where learning intention number 17 comes in. When you see cos and the square root of 3 on 2, for now we're going to ignore the sign and we're going to ignore the 2x. We see cos and we see root 3 on 2. What should immediately jump out in your face is the exact value for this. So as soon as you see cos, you should be thinking, what angle can I give to cos so it spits out root 3 on 2? What angle is that? I'm hoping you're thinking of it before I tell you. So the key angle, what is it? I want you to think about it first. What cos of something is root 3 on 2? What is that angle? It's pi on 6, or 30 degrees. Cos of pi on 6 is root 3 on 2. That's why you need to memorize those exact values. Cos of 30 degrees is root 3 on 2. Cos of pi on 6 is root 3 on 2. Alright, so that's our key angle. Then you have to do symmetry. So symmetry isn't like algebra. We're doing symmetry now. You have to look at your unit circle, and you can remember that that is a terrible circle. Let's do a better circle. And you have to remember that everything's positive here, only sine's positive here, only tan's positive here, only cos is positive here. And pi on 6 is somewhere here. There's pi on 6. Now, we're looking for the places where cos gives a negative root 3 on 2. So here cos gives positive root 3 on 2. So the places we want to be are here and here. Can we see that? Because sine's positive here, so that means cos must be negative, and tan's positive here, so that means cos must be negative. Now we can solve our equation here. So let's see, well, 2x equals, this is pi, and we're going back pi on 6. So it's pi minus pi on 6. So either equals pi minus pi on 6 or pi plus pi on 6. See that? So that's pi on the unit circle. So it's either pi minus pi on 6 or pi plus pi on 6. Now, because we all are very good at fractions, pi minus pi on 6 we know is 5 pi on 6. Pi plus pi on 6 is 7 pi on 6. Are we done? No, not at all. In fact, if we just stop there, that would be wrong, because We want the general solution. The general solution says that if you're at 5 pi on 6, there's 5 pi on 6, you can go round as many times as you like to get that same solution. You can go round. So you can go around once, you can go around twice, you can go around again, you can go around again, you can go around backwards. In algebra, that's the same as saying adding or subtracting lots of 2 pi. So let's write this up here. So we have 2x equals 5 pi on 6 plus 2 pi k, where k is going to be an integer, a positive or negative whole number. So we're going around, round, 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 or 7 pi on 6 plus 2 pi k. We have to be fancy here. We have to say where k is an element of the integers. Boldface said there. So k is an element of the integers. Alright, so we've got what 2x is. Let's divide everything by 2. 5 pi on 6 divided by 2 is 5 pi on 12. 2 pi k divided by 2 is pi k, or 7 pi on 6, so that becomes 7 pi on 12 plus pi k. That's a valid final answer. You should also be comfortable with making the denominators the same, so you should be fine with 5 pi plus 12 pi k over 12, or 7 pi plus 12 pi k over 12. So what I've done there is I've made times the top and bottom by 12 and added those two fractions. So that should look okay too. Could be factorized. You might see it as they might decide to take out the pi. And they'll take out the pi over here. There's lots of ways to say the same thing. So that's the same thing as well. All those are valid answers. So the reason to be aware of it is for multiple choice questions, where they can say which one of these is the general solution to 2 cos 2x plus root 3 equals 0. So that's why you should be aware of it. Alright, well what does this look like on the CAS? So let's check our answers with the CAS. So I can get the CAS up here. Let's check our answer. So here's our equation. You could use the solve function, but I quite like using the zeros function. It won't be obvious yet. I'll show you why in the next part, but let's try using the zeros function. So what the zeros function does is it lives at menu 3, 4. You don't have to put the equals 0, so you just put the equation and it figures out the values that make it 0. And I'll show you why I like that. I'll punch in the equation here. Trig, we want the cos, move over to the cos. Well, appears to be frozen. Oh, let's try again. Open that up again. Nope, it appears to be frozen. Okay, I'm going to figure out why that's frozen, and in the next video I'm going to show you the solution to this with CAS, and I'm also going to show you how to find a solution over a restricted domain. And if you have been, thank you for watching.